Next topic I'm going to talk about in this chapter is filter circuit. So filters, what is a filter? It allows a designed signal or desired signal, sorry. And it allows only desired signal and rejects the remaining signal. Okay, that's called filter circuit. It allows the desired signal. There are two types of filters. One is active filter and passive filter. So what is active? Basically it is made with operational amplifiers. Passive filter made with RLC elements. Okay, so active filter is made with operational amplifier, passive filter is made with RLC elements. So here active and passive, both of them have different types. One is low pass. So if we made a filter with operational amplifier, that's an active low pass filter. If we made with RLC element, we'll call that as passive low pass filter. So in this class we never talked about operational amplifiers, so I'm going to talk about only passive elements or passive filters. So one is low pass, high pass, and band pass and band stop. Those are the four different types of filters. Okay, so I'm going to talk about low pass filter. So it allows only low frequency signals. So low pass filter is, it allows only low frequency signal. Why do we need filter basically? So for example, if you look into your radio circuit, okay, if you look into the local radio station, here we have KMUW, which is 89.1 megahertz frequency. Okay, so 89.1 is a little bit high frequency. So the filter circuit is going to filter out all other frequencies, and then it take the signal at that 89.1 hertz frequency. Okay, so filter is nothing but it allows signal, wanted signal, and rejects the unwanted signal. That's what a filter is. So low pass filter is, it allows only low frequency signals. So if I draw a waveform, okay, that's omega x-axis, and that is the signal strength, hj omega. Okay, so low pass filter is going to allow signals at low frequency, so we'll see signals only in this shaded area, and the remaining area we don't see any signal. Okay, I'm going to design a low pass filter by using RLC circuit, a passive element. So if you look at a RC circuit, resistance and capacitance, what is the behavior of capacitor in DC? So here is my V input, I'm going to take my V output, okay, across the capacitor. Now what is the behavior of capacitor in DC? Once it is fully charged, it will act like an open circuit in DC. So if my frequency is 0, what is the output voltage in steady state? So my output voltage is going to be high. Now as my frequency is increasing, okay, so as frequency increases, this value is nothing but this is 1 over j omega c, that's a capacitor reactance. So as omega increases, this value goes down, down, down. So at high frequency this is almost 0 at high frequency, and V naught is going to be 0. Okay, so basically you can see it at low frequency, you will see the output. When it comes to the high frequency, your output is almost 0. So this is simply a low pass filter. now where do you find the cutoff frequency? I mean, at what point the signal is going to cut off. So in this case, what I'm going to do, I'm going to find a transfer function. A transfer function is j omega equal to v naught over vn of j omega. Okay, so output value v naught equal to, let me say I current is passing through it, I times 1 over j omega c over I times r plus 1 over j omega c. Okay, I get cancelled out, so I will end up with 1 over 1 plus j omega rc. This is our transfer function for the given low pass filter. Now to find out the cutoff frequency, what I'm going to do, I'm going to say hj omega or to find out cutoff frequency, I'm going to say h omega j omega, or the magnitude. I'm going to take only magnitude, h omega, not j part, it's just omega. I'm just taking the magnitude. H omega equal to 1 over square root of 1 plus omega square times rc, or omega c plus rc times square. Okay, so this value is nothing but 1 square plus omega square r square and c square. This is the magnitude. Okay, now if I take this omega c, which is cutoff frequency, omega c is cutoff frequency. So the cutoff frequency for any circuit is going to be, let me take omega c equal to, let me take that value equal to 1 over rc. If I take the cutoff frequency is 1 over rc, this value becomes 1 over square root of 1 square plus 1 square, which is 1 over square root 2. Okay, so the voltage as frequency changes, if I draw another line here, voltage across capacitor, it's going to be something like this, exponentially decrease. Okay, now the cutoff frequency is at what point the signal is going to cut off. We'll see that value as that's the cutoff frequency signal. This value must be like 0.707, which is square root 2 times the final value, or in this case initial value, square root 2 times v naught, not v naught is the initial voltage. Don't take that as output. In this case, let me take that as vc equal to initial voltage across capacitor. Okay, so that omega c cutoff frequency for low pass filter equal to, in RC circuit it's 1 over RC. Thank you.